you're probably going to be bored. Because this is my, like, normal app dev talk. Just for the record. But you're welcome to stay. I love you. I love all of you. I really do. But, I don't know how to use this clicker. My job in this talk is to keep your company off this slide. That's the whole reason we're here. Are we cool with that? Who can tell me what this slide is? That's right. These companies have all been popped, have data leakage due to application vulnerabilities. All of them. This is the OWASP top 10. I'm not here to talk about the OWASP top 10. Frankly, I don't know how many people know this, but this list is actually kind of a marketing ploy. It's really not. Okay, so the first line says the OWASP top 10 is not your application security platform. You should not develop your application security processes based on the OWASP top 10. It is a marketing gambit. It is a splashy way to get people to pay attention to application security. It's brilliant, and the people who put it together are way smarter than me. They have access to incredible amounts of very useful data, but that's not the way you build an application security platform. So we're going to talk about something a little different today. We're going to talk about 4 things, and where these 4 things came from was from my experience after being a dev for 20 years, which there aren't many people who do that, and then and for the last 10 of those, kind of leaning more and more towards the security side until eventually I fell over the cliff, and I've basically done nothing but application security for the past 4. So yes, I've got 24 years in the industry, and that is why I have this. So I'm talking about the gray hair. So who am I? My name is Bill Sempf. The @ is in front of my last name. If you don't use Twitter, you should. Not because you should follow Taylor Swift or anybody, but if anybody used IRC back in the day, does anybody still use IRC? Yeah, a couple people do. IRC is awesome. Twitter is like a really easy to use IRC that restricts you to 140 characters. It's a public conversation about anything. And I think that's just cooler than all get out. So I hang out there a lot. Please come join me. I'm a husband and father, an author. I've written on maybe 16 books for Wiley and, for Rox originally. Remember Rox Press when they were still in Birmingham? And then they got bought by Wiley. I call myself a software composer. That name comes from a book called Lorem Ipsum. If you have not read this book, I recommend you do. It's a 138-page children's book about computer engineering, and computer science, rather. And frankly, I learned more reading this book than I did in 8 years of college about computer science. It's brilliantly done. In the book, Lauren travels through these lands of fantastic builders and creators that represent roughly the kind of groups that you find in software engineering. For instance, there are the brutes that are using brute force. And so they're piling blocks on top of blocks, and then the blocks fall over, and they pile those blocks on top of more blocks. They say, well, it's okay, we've got a pile. We can put more stuff on there. Like that. One of the groups is the composers. The composers build beautiful things out of beautiful things. And that's kind of how I view myself. I stand on the shoulders of giants. I can't remember the last time I flipped a bit on a chip. I don't do that anymore. I take the work of other people, the beautiful work of other people, and create more beautiful things out of it. I'm an application... Okay, that doesn't fit on the slide. I'm a pen tester. I'm not really a pen tester. Pen testers are given goals, and then are expected to break into a system by any means necessary to achieve those goals, and then write up how they did it. That is not what I do. I take an application, so I have a small box, one app, find everything that's wrong with it, and write it down. You may know it as an audit, since many of you are in enterprise. I guess you could call me an auditor. Personally, I'm a home brewer, a lockpicker, and a ninja. And no, I don't mean like a software ninja. I'm actually 5th Q in Banjo-Jukai Ninjutsu. You only can see me up here because I'm letting you right now. I'm something of an insurrectionist. I've got labeled that in the dev space. In the security space, I'm kind of a fluffy white bunny. But in the dev space, I have this habit of saying exactly the right thing at exactly the wrong time, like when C-level people are in the room and stuff. So anyway. So this talk is the Developer's Guide to Pen Testing. And for this crowd, it is the how to have the talk with your development staff. This talk is very interesting. It's very flexible. I can give a slightly modified version of this talk to development managers or developers or security people or policy people or a lot of different groups of people. Because we're going to cover, as I mentioned before, 4 kind of big ideas based on what I have learned doing pen testing for the past 4 years. It isn't the same as what you find in the OWASP Top 10. The OWASP Top 10 lends to risk and other things, but the way you're failing your audits now and the way your developers are doing things lends itself to a different set of vulnerabilities. And that's what we're here to talk about today. Let's start with information disclosure. Convincing people not to spill stuff all over the web it requires kind of 2 core ideas. You can either use education or the clue stick. You can either try to teach people the right way and the wrong way to configure and design things so as not to spill information, or you can use the clue stick to smack them when they make a mistake. Let's talk about a couple of the things that maybe educationally would go a little bit better. I'm going to do this and I'm going to lose my connection, right? Nope. Server headers, right? Why do server headers matter? Who cares? Well, back in the day, when you still had to compile your web server, and yes, I was around those days. Once again, the gray hair. It's just, can't get away from it. The browsers needed to know what web server they were talking to because they could configure their experience. Obviously, these days, we don't have to do that anymore. Why do we not need that anymore? Because all that leads to is me going and looking up all of the vulnerabilities on your running web server, right? And I don't mean to pick on Apache. ASP.NET has the same problems. This is a configuration issue, but it's probably one of the easiest and first things that I run into as a tester when I'm looking at a site. First thing I do is hit your site, look at the response headers. If I see version, I go look you up. If you're not running current patches, that's game over, right? I'll write you up for just this, if nothing else. Just having the headers in there, if nothing else. But certainly, if you have vulnerabilities exposed, that's going to make for a bad day on this. So developers brag. They like to talk about what they do. They like to put their names and what they did in the headers of their HTML, their CSS, especially their JavaScript. Nowadays, we have all these fancy JavaScript frameworks. Word of the day.js, right? And everybody who ever puts anything into one of those open source things, they got to add a header with their name in it explaining what they did. Yeah, well, guess what? I go look up those names on LinkedIn, figure out all the companies they worked for, look them up on the forums, find out everything they've done, probably find the source code to stuff that they've written that isn't necessarily in the JavaScript or CSS. Even open source has its problems, right? If you leave your open source headers in place, okay, I might be able to figure out what you're using if you remove your headers. But if you leave the headers in there, it's guaranteed I'm going to go look at the list of known vulnerabilities for that package. It's just a guarantee. Developers like to get help. They like to ask for help. We like to, when we need help, we like to go and look at open source software that solved that problem previously. It's a very common way to go about things. You go to GitHub, you search for something, find a package that does about what you want, find a class that's just perfect. I don't know, do I have a laser? Oh, I do. Perfect. You probably can't read that. This lighting is terrible. What I've written, what I'm searching for here is MySQL _ query $_ get. It's a way to find SQL injection in PHP source code. If I find an open FTP or something and get your source code, that's how I find all the SQL injection instances that I can then go exploit on the white box side, right? So there's 87,209 code results for that. Open source software isn't necessarily secure because lots of eyes are looking at it. That's what they'll tell you. But everybody's looking at it. How could there be flaws? Here's the reality of that situation. People get jazzed and write a piece of software that solves a problem, get permission to open source it. And then they leave the company. And the software's still out there. And it never gets patched and it never gets updated And only sometimes, if it's heavily used, do people even post on the comments, hey, this has got a major command execution flaw in it, and it needs to be fixed. And then maybe somebody will submit, maybe somebody else will get access, maybe somebody will patch it. Probably not. This slide is 2 years old. I remade it when I did this talk for Wintellect, and I really should update it in this deck as well. It's now up to 277,000 entries in 2 years. So it's, what, tripled in 2 years? But that's what we do as devs. We go and we find a class, a function in the open source world that'll solve our problem. We paste it into our code base, your code base. And it has these problems built in. We also like to go on forums and ask for help. Sometimes we go on forums and ask for help. We take the source code to our project and paste it into Stack Overflow. Sometimes we paste in the database password. Even if we don't, when I'm testing, I will use that information. The more I know about your underlying system, the better, right? So I find your username, your developer's name in the comments. I go look them up on LinkedIn. I go look them up on Stack Overflow. I get this big listing of pieces of source code they paste onto the Stack Overflow. I compare them to figure out what company they're from based on times, based on LinkedIn. I take all the file snippets that are out of the time they're working for your company. I put them in one big file, and then I strip it to look for unique words that are variable names, stuff like that. Then I go search sites like Pastebin for those words. Because Pastebin is how developers communicate to each other when they're trying to get help with something. So if I, as a developer, want to get someone's help with a piece of code, rather than email or IM them the entire code snippet, I will put it on Pastebin and email them or IM them the URL to Pastebin for the snippet. But that's public. The fact that they're not logged in and they didn't title it doesn't mean anything. I can still go find it because I know all the variable names, database names, repository names, stuff like that. Sometimes people put really awesome things on Pastebin too. I have no idea why people would do that, but neither here nor there. That's a PGP private key in case anybody can't read it. Internal services. All right, so this is your fault, actually, not ours, for a change. Back in the day, we wrote N-tier software, client-server type stuff, right? We build a Win32 executable sitting on top of some selection of libraries, usually in Windows world DLLs, that would communicate with the database via whatever proprietary database format was appropriate for that database. And everything was well and good until we discovered the internet and people said, hey, I got this great idea. Instead of exposing those DLLs as in some proprietary thing like DCOM or Corba, let's do it as something that can be spoken over the internet. Okay? So we came up with these web services. Two kinds of web services out there, SOAP and REST. This is a SOAP service. SOAP is very thick, rich, deep, expressive communication mechanism that's communicated over HTTP, just like the web, right? So the only thing that matters here, really, to you, is this method name and this parameter, right? REST, really skinny, thin, simple, just uses the HTTP protocol to communicate. Here's our method name. And here's our parameter. Really thin. SOAP has its benefits, of course, because with SOAP you can do things like guaranteed delivery and transactions and security and authentication and authorization and all these things you can't do any other way with REST unless you're going to depend on HTTP to do it, which is just a horrible idea. So we internally implemented SOAP and REST. Finally, we figured out that we can externally implement SOAP and REST, but we had this web server in between, right? So we still have the web server communicating with our underlying DLLs, and the services are all communicating to the public through the web server. So all of the markup and whatnot is all rendered by the web server. Are you following me here? We're moving forward in time towards this path where we have these kind of the rich client experience where we have heavy JavaScript frameworks up front that are communicating via AJAX, right? And with JavaScript and JSON back to the underlying services, or with SOAP if under certain circumstances, usually with AJAX and REST, communicating back to the web server. But the web server still had control of those underlying business methods. It still owned them. Those SOA services that you laid in so carefully in 2004, when SOA was all the rage, and we're like, oh, we can change our front end whatever we want if we do this, which was largely true. But then something really interesting happened in 2005. The iPhone was developed, and put in play. And now everybody has to have their iPhone app, right? So when we have all these new apps out there, and the interesting thing is that when the apps communicate back, they don't need a web server anymore, because they don't have to render their HTML anymore, right? The UI is all in the app. They need to communicate with those back-end services that have always been hidden in the DMZ, right behind the web server, inside your network, protected. Now, somebody went and said, hey, we got this cool iPhone app. Let's take all these services our web server is using and push them out into the public eye. Well, the problem with that is that those things are all now public. I mean, you don't see them as a user of your iPhone, but I do. I know they're there as your tester. So I can go and do things like get your entire data schema, because that's what web services are supposed to do. There's this whole concept called discovery. In SOAP, there's even a file for it, .disco. Not too many people use it, but it does exist. Certainly, WSDL exists, which gives me the entire framework of your method language, your domain-specific language for that set of services, right? So you've told me everything about how your business logic works under the covers. And once I know that, and am able to touch the service, all of the same attack service pieces that happen for your website happen for those web services. Have you submitted those to the same security rigor as you have your websites? I bet you probably haven't. And I will find that and I will exploit it. Let's talk about exception management. Remember, we're still on information disclosure here. I slid a little bit away from information disclosure because I get on a high horse about the services thing, but it's still information disclosure, right? You're spilling all the information about the way your methods work and the way your data structures work. So exception management is the premier source of information as far as web applications are concerned. If I can make your web server spit up bad errors, I will learn more about your application than almost any other way. And I make fun of PHP, but PHP is actually not even as bad as ASP.NET. Where we have something called the yellow screen of death. I'm sure some of you here on the Microsoft stack are familiar with this. By default, of course, this wonderful error message spits up actually a stack trace. Very helpful from the tester's perspective. So, what am I going to do? I am going to throw anything I can at your web server in order to make it spit up errors. I will attack the application. I will attack the server itself. I will attack your services. I will attack anything I can with any kind of garbage I can come up with in order to make it spit up errors, because those errors are how I map out how your application works under the covers. And I'm going to use my experience doing development to figure out how best to further attack the application. This thing does not like me. So what do we do to get rid of that? We do exception management, right? We use structured exceptions to have your application make good decisions about how to behave when things go badly. Developers are optimists. We all think nothing will ever go bad. That's the only way we can survive. Do not hold that against us. Trust me, so much bad stuff happens in the dev space. It's the only mechanism we have to cope. So what does exception management look like? Exception management, at its core, focuses on two things: trying and catching. Trying is where we put code in that we know may create an error. This code, of course, will create an error, right? Because we're trying to run process string on a null value. Presumably, process string is expecting a string, right? Or at least something. Instead, it's getting a null. It will probably get an argument null exception in C#, where we are here, right? So we are going to catch the exceptions we know might happen, and then catch everything else. Because process string might be in a DLL that got deleted by the admin. You never know. Right? Then that would be a totally different exception. So we have layered exception management, the security onion, right? It's in very small scale, right? This is the security scallion instead. And we are handling things we know could happen, handling things we don't know happen, and handling everything else because we want to handle things. Another piece of the puzzle is finally. Finally is what's run after try catch, where it's code that's run no matter what happened. Whether the code succeeded or failed, we are going to close our stream reader or whatever it is. And this is what it looks like in PHP kind of all together. All different languages support this. PHP finally started supporting structured error handling in version 5. Ruby supports it. Of course, ASP.NET and Java support it. Perl supports it. Everything supports it. There's absolutely no reason why you shouldn't be doing structured exception handling. Even services have a procedure for handling exceptions. Okay? In SOAP, it's called a fault. Strongly recommend that if you are using a service tier in your applications that you look towards this. It is a very important part of the whole structure, and many developers do not understand. Many developers that are used to developing in the web space still do not understand how to handle exceptions when they're dealing with SOAP. Now, of course, with REST, I don't have a pretty slide for this. I'm sorry, and it's really too bad because I could totally do something with this. With REST, of course, REST is just HTTP. So it uses the HTTP error codes, right? What is it? 100, everything's fine. 200, here you go. 300, it's over there. 400, you did something wrong. 500, I did something wrong. Isn't that right? Yeah, that's right. So if I ask for something that doesn't exist, if I ask for cars / Bugatti, it replies with a 400. I don't have any of those. If I ask for something and it goes and looks it up and the database is gone, it replies with a 500. Oh, I don't even want to talk about it. So no matter whether you're doing REST or SOAP, your services should handle exceptions in the way that the end client, the consumer, is going to expect them to handle it and not just barf up your platform-specific web exceptions. Any questions about information disclosure? Let's talk about injection. So injection comes down to a handful of things. Basically, I wish I had better slides here. I seem to be, there seems to be something missing that explains injection. So I will just talk about injection for a second. Sorry about that. So injection, right? Injection is where you send a command to something that the developer didn't expect. You can send it to a backend system. You can send it to a front-end system. Doesn't matter. Front-end system, it's cross-site scripting or cross-site forwarding. Backend system, it's X injection, SQL injection, LDAP injection, command injection, whatever you choose. It is a common failure of sanitization. Cleaning inputs. We should never trust anything given to us by anybody, right? For instance, JavaScript does not sanitize your inputs. Why not? Because the attackers aren't using browsers, and the browsers are what's executing the JavaScript. If you're expecting to protect your back-end systems, you cannot expect your JavaScript to sanitize your inputs. So all those fancy Angular applications that you have, the services underlying that they are calling better dang well be actually sanitizing the data that comes in using whitelists. Because the JavaScript that says, oh no, you can't put a bracket in there, I don't care about. Because I'm using an attack proxy to call those services anyway. Right? Outputs are the same problem, and this is someplace where developers have a real problem. Because they don't think about, if I got my data from that system, I need to clean it before I show it on the screen. And they don't consider that. It came from over there. It must be fine, right? This is where cross-site scripting comes from, right? I can go to system X, which has terrible input sanitization, input my data. It shows up on system Y, where I get the cross-site scripting vulnerability, steal credentials. Developers have a problem with not built here syndrome. And it is slowing the use of object relational mappers, which is one of the primary ways to prevent SQL injection, which is, it's A1 on the OWASP top 10 for a reason. It is the highest risk vulnerability we run into every day. Now, admittedly, in 2003, when we started the OWASP top 10, that was 2006, I think. Whenever it was. The first OWASP top 10, 69% of applications were vulnerable to SQL injection in one way or another. In 2013, the last time we ran it, it was down to 12%. So we're winning the battle, but the war still rages on. Those 12% of applications are extraordinarily vulnerable because, of course, with SQL injection, I mean, properly done by the attacker, we can download the entire database. Game over, right? There are still a large contingent of developers that believe that writing your own data layer is like, makes them a bigger person or something. You know, it makes them tough. And that's just really bad practice now. The ORMs that are out there today are good, easy to use, well vetted, not bug-free, but certainly much better than anything you're going to write in-house. And you should be using them. It prevents SQL injection at a high level. We always say SQL injection, parameterize your queries, right? That's always the phrase everybody uses. Honestly, it's just easier if you simply use an ORM to begin with. Then you don't have to worry about queries at all. You just let the platform take care of it for you. So eval is evil. The eval statement in JavaScript is something that shows up in all of these really hip new JavaScript frameworks. And of course, what that allows me to do is if, for instance, a developer were to ever do an eval on any piece of data that I can touch in any way, I can do a relatively sophisticated attack called DOM cross-site scripting, which never even sees your server ever. It's completely a client-side attack, and I can send a phishing email to your admin and get his creds pretty easily. So I don't mean to rage against JavaScript frameworks, but when your developers come to you and say, hey, we really need to use this cool new Angular.js thing. Angular isn't even new anymore, but whatever. The word of the day.js thing, take a minute and look, because some of them are pretty seriously flawed. On the XML side of things, when you're communicating, well, actually, even in JSON, but less so in JSON. Certainly in XML, when you're communicating, so passing back and forth large packets of data in XML, failure to use a DTD is damaging because I can very easily inject commands into your XML and do injection on your XPath. So when the devs get lazy and say, oh, the data changes too often, I'm not going to use a DTD, that's a really awful idea. JSON's the same way, right? But really, we can fix a lot of JSON problems with a no-sniff header, right? So if you're communicating with REST, once again, depending upon how you're doing it, with all these new frameworks, sometimes it's difficult to implement no-sniff. But a no-sniff header will prevent me from constructing an email that calls your underlying services with just a click. This is basically what we're doing, right? It doesn't matter where the data is coming from or going to. We've got to stay frosty. Trust absolutely nobody. Check everything coming in and check everything going out. Any questions on injection? I think I have 20 minutes. No, I have 20 minutes. I think I have 20 minutes. All right, so configuration. What kind of configuration flaws do developers get into? We leave files around a lot, right? We do things so that we can go look things up later. We will rename files, call them .old, .back, whatever. Leave them around so that we can look it up. See what change we made before. It's a really awful idea because I can find those files really super duper easy. It's not even close. I mean, it's really easy for me to find those files. Robots.txt file. Tell me all the places not to look. Yeah, that's kind of a bad idea, right? Does anybody even use sitemaps anymore? And what's up with that? Hidden files are a bad idea. Putting things up that you expect that I'm not going to be able to find is not going to work. I have a tool that probably many of you are familiar with called Burp Suite. If you're not familiar with it, you should get familiar with it, at least in passing. It's specifically designed to test applications. That's what it does. It's a web application testing proxy. When I'm in front of developers, I ask how many people have used Fiddler for debugging, and everybody raises their hand. Burp is Fiddler. It's a proxy. It sits between the web client and the web server, and it disconnects all of the communication, the request and response pairs that go back and forth so that I can look at them all, tweak them to my liking, and send them to the web server in whatever configuration I see reasonable. One of the wonderful tools it has is the discovery tool, which I can go and configure and say, hey, so here's my scope, Sempf.net. go in there. It's an ASP.NET site. Look for any file that might have been renamed. And it will try hundreds of thousands of combinations of file names. And I've never failed to have, well, that's not true. Very rarely have I failed to have it come back with at least a couple of files that somebody slipped in there. You know, default.aspx. 2015106120 0126, whatever. So that the developer renamed because they had to make a change on the fly, and they left it up there. Of course, the web server doesn't know to render that, doesn't pass it through the preprocessing engine, so I get it in raw text, which means I have your source code again. This goes back to me looking things up on Stack Overflow. The more source code I have, the happier I am. When Burp finds all those things, it just sits and adds them to the sitemap. So when I do all the other scanning that I will do, or the other broad stroke testing, those files that I've discovered, that you have up there that you're hoping nobody's going to find that I found anyway, those get tested too. Not a lot of people know that Visual Studio, up till 2010, would create a .bak file of any changed ASPX file, or ASPX.cs or VB file. It would create a .bak of that and save it in the same web root. So if you xcopy deploy your web application, all those files would go up with it. Lots and lots of companies are still using Visual Studio 2010. Many companies are still using 2008, but that's neither here nor there. All of those who use xcopy deploy are then copying up all those backup files. They never look at them. They don't know. They don't care. They don't look at those directories. You don't have to. That's what an IDE is for, right? Makes it so we don't have to look at the freaking files. I want to look at my pretty listing. So all those files get put up there, and I find them all because the first thing it checks is .bak, I think. And then I have all the source code to your whole application, which is not the way it's supposed to work, but that is the way it works. So what do we do? What we do, I need a slide for this too. What we do, it's already such a long talk, I don't want to add slides. What we do is we don't deploy those files. Use deployment scripts. Don't use xcopy deploy, right? Learn a little PowerShell and only deploy the files that are absolutely needed for the application. And this problem will go away. Or tell your developers not to rename files. That's another thing. So file permissions are fun. Everybody's had a permissions problem with a web application, right? Where they go in, it's like, click, click, oh, what do you mean I don't have permissions to run that? I should have permissions to run that. Well, let's add this role. Let's add this. Oh, heck, we'll just add them to the everybody group. See what happens. Everyone's done it. I know I've done it. That's fine. Use it. I mean, figure it out, debug it. Please remember to go turn it off. I run into this like once a month. It's ridiculous. Any questions on configuration pieces? You guys are really quiet. Am I that good or are you super confused? I'm not sure. A little of both. Okay. So here's a couple of big ideas on the topic, maybe. One of the things we need to do as a whole team here is to make debugging easier in production. A lot of the things that developers do, like the permissions tweaks and leaving files around and pieces like that, are because we're not given the tools to fix problems when they come up. We leave trace on, we write in backdoors so that we can get in and fix things when we get the phone call at 3 o'clock on Saturday morning. Okay? When a problem happens, a P1 ticket comes up, and it's robot. Oh, we got to dial up the developers or whoever's on call and get them rolling on this and like that. It's just mechanism. But you need to understand that the person who's making that call 85% of the time does not have the tools to solve the problem. And they're simply relying on experience and wit to solve it. So as a group, we need to make solving those problems easier for developers. I pick on ASP.NET again, but it's not the only one. I mean, almost everything has some kind of trace turned on. I'm still seeing a lot of organizations building their own encryption implementations. Please stop that, okay? I don't care if your lead developer has a 2213 chess rating. I don't care, okay? Here's the problem. As developers, the reason we're doing this is because we like to solve problems. Okay, it's a challenge for us. It's a puzzle. Yes, okay, you can make good money as a dev, but you can make good money in a lot of different ways. Development is very demanding. The people that are in this business do it because they enjoy solving the problems. The issue is that they confuse the complexity of a warehouse management system with the complexity of an encryption algorithm. The two are not the same, and they do not realize that. None of the devs on your team are this guy. That's Bruce Schneier, for anybody who doesn't know. None of them are as smart as him. Probably all of them put together aren't. So Bruce wrote an encryption algorithm that, and I'm speaking on your topic here, so forgive me if I get a fact wrong. But Bruce wrote an encryption algorithm to go in for SHA-3, right? I think that's right. For SHA-3, I'm sorry, this thing doesn't have my notes, so I can't, the really picky facts I can't pick up as easily. I have to go by memory. And the government runs this, right? There were 64 algorithms put in for SHA-3, and it went through 5 runs through a vetting council over the course of like 7 years or something. It was ridiculous. And then he still didn't win. He still didn't win after all that. Encryption algorithms are remarkably difficult to implement. Just because you can't fix it, that just means, or you can't break it, just means that you can't break it. I don't know anything about encryption. I'm not a mathematician. I actually have trouble, like, sometimes even, break it, like when I have a known bad SSL implementation, exploiting that is difficult. You have to be a good mathematician to do that. I mean, I don't mean like arithmetic mathematician. I mean true math, understanding of mathematical concepts. And that's sometimes a struggle for me, even though I'm supposedly good at all this stuff, right? Yet, I remember, wasn't even too long ago with a unnamed state agency where, our lead developer came out with this awesome hashing thing. It's better than anything out there. So we're using this custom hashing to put our stuff in there. And the bonus, of course, was that it had something hidden in it so that you could get, I don't know, the roll out or something if you knew the secret sauce. I don't even remember what the deal was. And even with my lukewarm intelligence, it took me about 45 minutes to reverse it. It's just nothing you should do. Is build your own encryption methodologies. Don't do it. Don't let your devs do it. Something else not to build is an identity system, right? You build your own identity system, this is what I get. There is no reason that you should be building a system that stores roles and users and such like that for most environments. We have really good systems that already do that. Active Directory is a great example, okay? We have open ones if you're writing public web applications using things like Google or Facebook for authentication. It's a great idea. But there's zero reason that you should be building your own system to do identity. If you have to write your own application and you can't use one of those built-in things, use one of the identity management systems to come with your platform, like ASP.NET Identity, for instance, or the Java equivalent, which has slipped my mind at the moment. Everything has something built in you can use. Yes, I know it doesn't have tiny little feature X that you need. It's probably extensible. Just learn the API and fix it. If you need to convince your developers about it, just remind them how difficult it is to... Oh, there goes my laser. This thing's dying. Just remind them how long it takes to build. Okay? It's a pain. So don't do that. Use what's baked into your application. So where does that leave us? Well, the first, does anybody have any question about big idea stuff, aside from encryption questions? Because I can't answer those. I can, but I'm not gonna. Okay. I'm gonna do it all the time. So, the first thing I want you to take home is that your development staff needs to treat security requirements like the requirements that they are. Whether they are upfront requirements between scope and requirements that is in the SDLC that are being given to them that they're going, yeah, okay, we'll deal with those later. Like, authorization requirements, which are very common. Hey, by the way, the managers need to be able to do this, and the admins need to be able to do this. Okay, we'll work on that. No. Treat them like the requirements they are. They are business requirements like anything else. Or, if they are the bugs, well, actually that comes up later. Yes. If they are the bugs that come out of my pen test reports. I hand you a nice report with 26 vulnerabilities. Those are bugs, just like the button's the wrong color. Okay, it goes in your bug tracking system. Nope, I don't have that. It goes in your bug tracking system, and you treat it like any other bug. Cross-site scripting is just like any other bug. Goes in bug tracking, and the developers, it gets rated, it gets given to a developer, and the developer fixes it like anything else. It doesn't go in your separate security system. You don't just hand the report to the lead developer and say, fix these. They get added like any other bug. Educate yourself about the third-party packages your developers are using. Whether it's OAuth from Twitter, or some open source package they've downloaded, or something like Telerik. Take a minute and learn about it. Learn about the vendor, or the open source community around it, whichever it happens to be, and what the risks actually are. We tend to just go, oh, third-party component risk, okay, that's a checkbox. That's a horrible idea. Stop doing that. Take a minute and learn a little bit about what they're using. You'll be able to make much better decisions about the application. If you do not have a Google alert set up with your company name, maybe your company's database names, key system names, you should be doing that. I rarely come across an application, I almost can say never, come across an application where if I get an internal value where I can't go look things up about it online. Server name, database name, variable names. I'm not saying you have to put all your variable names in Google Alert, but if you have the big values, you will know before I do, which is a good idea. Because if I know about it, I'm going to write it on the report, and that's not what you want. Use deployment scripts to deploy your application. You don't have to use Octopus Deploy or whatever the new hotness is. That's the new hotness, I think, still. You don't have to spend thousands of dollars. I don't care. Just stop saying X copy plus X web folder and copying the whole damn thing up there. The devs are leaving cruft in there. Tons of it. Yes, we have source control. I understand that. We don't use it. And we do. We check in our code. We check out our code. We still rename our files and do backups locally. Nobody trusts the source control. They don't. So, if you don't have an ops team, take it on yourself and write scripts to only copy what's absolutely necessary to prod. Take a weekend off. Do the deployment on Friday with everything stripped out of it and see if the app breaks. And if it doesn't, you've won. And if it does, you have the whole weekend to fix it. Unless your site's used on weekends, then I don't know what you're going to do. But figure it out, because that's the best way you're going to... Oh, my goodness gracious. Fortunately, I'm almost done. You're going to get there. Most importantly, stay involved. And I didn't do this talk at the beginning of this, but how many devs do I have in the crowd? People who check out code in the morning and check it in the evening. I know you. I know you. Anybody else? That's what I thought. Oh, really? Okay, I got a couple. The devs are all really shy. They're all like... The rest of you aren't. You have some other role in the organization other than cutting code. I mean, I'm sure you cut code some with script or configuration or whatever, but cutting code on a product. You need to stay involved with the development team. Frankly, they probably don't like you. No, I don't mean that as a joke. I'm serious. They probably don't. I never did. Even when I was heavily involved in the development community, and there's people in this room who have watched me get involved in the security community. I'm in the security community. Watched me get involved in the security community in the last 15 years. Even when I was involved in the security community, I didn't tell people I was a dev because we don't like you and you don't like us, and that's the way it is. Get over that, because it's making things worse. All this effort that OWASP and other organizations are doing to try to bridge this gap are getting crushed by that. Go and sit in on their meetings. You know, go to a stand-up. I know it's boring. I think they're boring. I go to them. I run them. But get involved. Get involved. Learn about the applications. Learn about their process. Sit in with somebody and watch them work on a project. You know? Largely speaking, the developers want to make things right. They don't know about the vulnerabilities. I mean, I just today, between the talk that I went to this morning and this talk that I gave today, I went in and did a small retest for somebody on something that I'd written. And she did a great job. She fixed like 17 vulnerabilities and added 4 new ones. I've got to write up 4 new ones when I get home today. It's not because she's a bad person. She didn't know. She didn't know that if she puts a very helpful message up saying, oh, I'm sorry, that email isn't in our system, so I can't send you a forgot password link, then I'm going to use that to harvest passwords or emails. She didn't know, so I'm going to have to tell her. All right? You got to treat the devs as part of the team. You got to show them what to do right, and they will. Hey, look, there's all the bullets. Notice I didn't have any bullets. There's all the bullets. Do I have any questions? You can ask me afterwards. Probably most of the questions aren't. I know how security cons are. You can't actually ask the questions because they're not the kinds of things you can say in public. But I will be around for a little while. I have to go to a dead meeting tonight, but I'll hang around for a little bit. If anybody has any questions, you can find me on Twitter at Sempf. Feel free to ask me there. And I'm all over the net. I'm easy to find. So if you want to email me or whatever, I'll be glad to chat with you about it. It's a great, obviously I enjoy this topic, so I'll be glad to talk with you more. But that's all I've got for today. Thank you very much. Hope you're having a good con.